Hey, Casey here from Software of America. Today we're going to go over a mathematical phenomena that I discovered. It deals with polynomial functions. So as we can see here, we have these polynomial functions. So x to the 0, x to the 1, and x squared. And I realized that if you subtract these numbers in a logical way, you always get to 0. So that's pretty interesting. So let's do this out. So right now we have x to the 0 is equal to 1. Yep. So if we plug in a 1, we get 1. If we plug in a 2, we also get 1. Anything to the 0 is 1. So right here, we take the second number and we subtract it from the first, and we get 0. By the way, this is like a calculus 2 technique where you're trying to find sequences in series. So I was just randomly doing this and found a pattern. So anyways, onto x to the first. We plug in 1, we get 1. We plug in 2, we get 2. We plug in 3, we get 3. Great. So now we do the same type of subtraction. We start all the way to the right, and we subtract it from this one. Cool. Boop. That's how we get this one. Next, we take this 2, and we subtract it from this 1. Bang. That's how we get 1. So how do we get 0? We do 1 minus 1, which is 0. Wow, they look similar. It's just built on one more layer. As you can tell here, that x to the 0 had 2 levels and x to the 1 had 3 levels. What do we think x to the x squared is going to be? I think it's going to have 4 levels. So 1 level, 2 level, 3 level, 4 level. Great. We're noticing a ton of patterns here. Anyways, so let's go through it. X squared, if we plug in a 1, we get 1. 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. Great. So we do the same thing. 16 minus 9, 7. 9 minus 4 is 5. 4 minus 1 is 3. Great. Keep going. So we get 7 minus 5 is 2. 5 minus 3 is 2. Awesome. So then we get 2 minus 2, which brings us to 0. So something pretty interesting to note is that you start seeing a lot of sequences in this. This is basically a different form of Pascal's triangle, and it's really interesting. And I could talk about these patterns literally forever because it continuously shows up. But I'm going to digress and show you something that I coded up, just so we can see that this is actually true or not true. So we're going to run this, and what it says is it asks us for the exponent. So like we saw before, x squared gave us that triangle, which we can see right here. It's just inverted. So we get 1, 4, 9, 16. We go all the way down. Boom, we get 0. Okay, let's run it again. What if we try like the next number after that, 3, we expect to have 5 levels. So level 1, level 2, level 3, level 4, level 5. Whoa, same thing. Okay, let's run it again. We'll do 5. Holy shit, there's this pattern going on. And something interesting to look at is, right, if we take 6, 120, what would the next number in the pattern be? There's patterns between all of these numbers here, and this is so fascinating. I've never seen anything like this in the realm of mathematics, um, besides Pascal's triangle. But I found it, and I'm pretty excited about it, and I was able to code something to prove my thoughts. Everything will come out to 0. Um, So yeah, I really hope you guys are interested in this type of stuff. and I'll keep you updated on some of the interesting things that I find. But let's try out 12 maybe. These numbers are fucking crazy now. And hey, goes down to 0. Quite interesting if you ask me.